Chapter 4, Lesson 5, Graphing Linear Equations in Standard Form. Today, the equation is going to be written slightly different, and this is another option for us to graph them. On your quiz, on your tests, on your assignments, on homework, when it gives you a specific method to use, you have to do that. Otherwise, if all it says is graph, any of these methods that you want to use, you can use. A table, like we talked about before, you can use your slope-intercept form and graph it from there, or you can use these intercepts, is what I usually call this lesson, graphing using intercepts, because they're written in standard form. When we talk about those intercepts, you're going to hear us talk about y-intercept today again and initial values. Standard form is when the linear equation is written like this: some number x plus some number y equals c. Now usually I will see that written, or I used to write it with a capital A little x plus a capital B little y equals a capital C. This is not in y equals mx plus b. The y is not by itself. The x and y today will be on the same side. And instead of having to do different things, having to rewrite the equation or do a bunch of stuff, there's a neat way to solve these. Maybe you like it, maybe you don't. It's just a method, another strategy for us to graph equations. Here it is. Graph 3x minus 2y equals 2. What I'm going to do, I'm going to rewrite that over here where I have a little bit more room to do my work. You, on your assignment, you're going to write down the original equation. So that's going to be 3x, and I'm going to switch that to adding the opposite. So I'm going to make sure that's a negative 2y equals 2. Now what we'll end up doing is we're going to graph the y-intercept and we're going to graph the x-intercept. Remember, any point on this line, here, 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 the y value, the x value on all those coordinates is going to be 0. So what we do is we just plug in zeros to these equations and graph. So if I want to find the y-intercept, I'm going to plug a 0 in for the x. Well, what happens there? Well, that's the nice thing with this. 3 times 0, well, that's going to leave us with nothing there. That just is gone. So a negative 2y equals 2. Solve that equation for our y-intercept and divide both sides by a negative 2. That gives you y equals a negative 1. Circle that up. That is where you're going to end up graphing your first intercept. Your y-intercept's at negative 1. So at negative 1, make a little dot there for your y-intercept. That's first one. Now we're going to find our x-intercept. Where does that line cross here? Note again, every spot, any spot we pick on here, your y value is 0. It hasn't gone up or down at all. That means we're going to go back to that original equation. I'm going to rewrite it so you can see it. And this time, since our y value on this is going to always be 0, because we can see that here on our y-axis, the x-axis, the y value is always 0. Plug in a 0 for that guy, which is very nice because those guys cross off. You're left with 3x equals 2. Divide by 3. And you get that your x-intercept, your x value, is at 2/3. Not so nice to graph because you kind of got to get it right around in here, but we'll just get that in there as best we can because our x-axis crosses right there. You have 2 points. You put both intercepts down. That's enough to make a straight line. So grab your straight edge, draw a line in. Connect the 2 dots. Make sure you have arrows on both sides, and you're done. That's it. We've graphed our x-intercept here and our y-intercept that we found here, and we're done. Graph 2x plus 4y equals 12. Notice it says using intercepts, so we don't have to worry about trying to rewrite this into y equals mx plus b form and solving it from there. We don't have to do any of that stuff. No. So all we're going to do is we're going to use the intercepts. To do that, somewhere you're going to write down the original problem. And then this method, we just start plugging in zeros. Remember, while we're looking at our y-axis, the value for the x will be 0. So you plug a 0 in here. Very nice, because this cancels out. And when you write it on in, yes, you technically could jump right away to 4y equals 12, but please show this step. We need this mental memory or muscle memory of how to do this, because then what we solve here, and here's what I need to stress the most. Make sure you put down y equals, and then you've got that 3. That's a reminder that this 3 needs to go on your y-axis, and that y-axis is the vertical. So you need to go positive 3 and put a dot there. That is your y-axis. That is your y-intercept at a positive 3. Now go back and do the same thing again using a 0 for the other variable. Write the equation in. Yes, you can jump to it, I know, but write it on in, especially here in your notes. Now again, because we are looking for our x-intercept, that x value is going to be 0. The y value is going to be 0. So you plug in a 0 there, which is very nice math, because, yep, once you've done it, it cancels out. You're left with 2x equals 12. You divide both sides by 2. Run out of room, so I'm going to sneak it over here where x equals 6. Circle that up. That's not your final answer. That's where your x-intercept is at. That's the point 6, 0. So we need to graph that. Count carefully. Go over 6 spots. And put a dot. You've got 2 points. Now you can connect them with a line. I always recommend making the line nice and long. You can make it short if you want to, but make it long because you never know if they're going to ask you a question. Again, we got these points down here from your x-intercept, 6, 0, and your y-intercept, which is 0, 3, which again we found right here. Graphing those two, you plug in 0, solve, graph it, plug in a 0 in the other one, and graph it. Again, because we're looking at our initial value and slope, we're looking at being able to do y equals mx plus b, but right now we don't need to rewrite it. If they didn't ask us for that, that's all we're going to do. Graph it the way they want us to graph it, using intercepts, or if it just says to graph, this could be the method you get to use on your evaluation. Graph this equation, again, using intercepts. No need to rewrite, although when I rewrite it down or write it down originally, I am going to switch that to adding the opposite. And for help, what's the coefficient with the y? What's in front of the y? How many y was there? There was a little 1 there, so I'm going to write that in that it's a negative 1y equals negative 5. You can start plugging in a 0 for any one you want. I'm going to start with that y-axis. So again, when we're graphing on the y-axis, our x value is 0. So that's why I plug in a 0 in there. It's also nice with the math. Cross that on off. Negative 1y equals negative 5. Careful. When you divide by negative 1, we need to do that so that we see y equals 5. So your y-intercept is at the point 0, 5. So when you see that, don't box it up. You're not done. You need to come over there and graph it. Put a dot at 5. And now we do it one more time and plug a 0 in for the other letter, the other variable. So let me rewrite that equation again. 5x plus a negative 1y equals negative 5. And yes, when we plug a 0 in for y here, you might want to jump. But please, for your notes, rewrite the whole equation. You can see that negative 1 times 0 cancels. You're left with 5x equals a negative 5. Divide both sides by 5. Watch your signs with mental math or a calculator. You get x equals -1. Again, that's your x-intercept at -1, 0. If they ask for the coordinates, that's how we got that. And again, why do we plug in that 0? Because anytime we're looking at the x-intercept, the y value is always 0. So graph that -1 right there. I'm going to use this to make a bigger dot so we can see it. We've got 2 points. Now grab your straight edge and connect them. Make sure you've got arrows on both sides, as those are points for me in my class. Otherwise, you have graphed the equation. Multiple different ways we can do it, but since they said using intercepts, this is the method. You plug in zeros, you get 2 points, and you're done. You can also do this within a word problem. You have $2.40 to spend on grapes and bananas. We've got the equation right here. Again, this $2.40 written as 2 4/10, 2.4. Graph that equation where x is the number of pounds of grapes and y is the number of pounds of bananas. Any way you want to graph it, you can, but since today we're talking about graphing equations in standard form, that's what it's going to do. Sliding on down. 1 2/10 x plus 6/10 y equals 2 4/10. Solve for 1. As usual, I'm going to plug in 0 first for that guy. And then rewrite the entire equation. That was nice. It cancels. 0.6 or 6/10. Y equals 2 4/10. Divide both sides by your 6/10. You get y equals 4. You now have a spot to graph your y-intercept. From there, you go back to that equation. If you're like me and ran out of room, you can go to the next little spot available off to the right or to the left. You can go just above, or you can bleed or continue down below. Since I've run out of room, I'll create a new page. I'm going to put in a 0 for that y because that's where my x-intercept is at. It has a y value of 0, so whether you want to put a dot or parentheses as you plug it in, it doesn't matter because, of course, it cancels out. So many of you want to go straight from that last spot or even this equation and want to jump right down to here where it says 1.2 or 1 2/10 x equals 2.4, and this is an understandable jump to skip this step right here. But if you could just keep writing that out, it seems to help us with muscle memory, with retention on how to solve these when it comes later on to an assessment or a test, a quiz or something else. So do that, because then, yes, I know it's an extra step, but you'll remember, and here you see that we got x equals 2. So your x-intercept is at 2. Go back to the graph and graph it. Put your dot on the x-axis, and then from there, grab your straight edge, put them on either edge. So you're going to put your straight edge on this point, and then connect the dots. It has been graphed with arrows on both sides. Don't miss part B or C if there are those, whether on your homework or on Excel, a worksheet, a review. When we're looking at it, it says interpret the intercept. So on this slide here, we can see that our y-intercept is 4. So if y is 4, that's where we're going to have to come back to the problem. Go back to the word problem and look where it said y represents pounds of bananas. So interpret the intercepts. Well, if y is 4, that means at most I can buy 4 pounds, and that's a cursive LBS, short for pounds, of bananas, along with 0 pounds of grapes at that spot, because that's what the intercept stands for. 4 pounds of bananas and 0 pounds of grapes. Well, then it says interpret the other one where it was x equals 2. Again, go back to the word problem. Go back to your textbook where x is the pounds of grapes. So when we talk about that, at most, I can buy 2 LBS, 2 pounds grapes. Or that intercept means I can buy 2 pounds of grapes and 0 pounds of bananas. And when we talk about this equation we've seen before as we looked at some of our labs and activities, that anything along this graph here between these two intercepts work as points. Because I can buy uneven pounds of grapes or bananas, I can find other amounts that would work for those, whether I bought 1 pound of grapes, what that means for how many pounds of bananas, or even a half pound of grapes. If you're so inclined, we can look at those, but it doesn't ask for that. It just said interpret, which we have done, and we have graphed, so you can move on. Today, we're looking at graphing equations in standard form. So we were able to use our initial value or y-intercept, and then we can go from there. You can see a lot of our skills talk about writing equations or graphing them in that form, but if it doesn't make us change it, doesn't make us rewrite the equation, then just graph it so that you can accomplish that. Today, that's all we're trying to do is graph linear equations written in standard form, where it's the x and the y are both on the same side. And if you wanted to see it again, big A, little x, plus big B, little y equals big C. Otherwise, when you see it this way today, you plug in a 0 and solve, then plug a 0 in for the other one, and make sure you graph your intercepts at the correct one. X-intercept on the x-axis, and the y-intercept when y equals something on the y-intercept going up and down vertically.